Hello, my name is Will Simonson, and today I will be talking about Physics 1, Lab 1, Constant Velocity. The purpose of this lab is to analyze Newton's second law and how an object moves at a constant velocity with no outside force acting upon it. In the real world, there can be many forces acting upon an object, such as friction or air resistance, that oppose the direction of velocity. Models and fundamental principles. Newton's second law is the acceleration of an object is dependent on the force acting upon an object and the mass of the object. So you can see here the force is equal to the mass times the acceleration. This sums up Newton's law, and any of these variables can be manipulated to solve for one another, and impulse and momentum can also be derived from this equation. The position update formula is used in this lab to calculate the final position of an object based on its average velocity. You can see here that the final position vector is equal to the initial position vector plus the average velocity times the change in time. So you can loop this equation in GlowScript so that you can find a final position of an object with a constant velocity, or find the average velocity. A free body diagram is often used in physics, and it helps relate force and motion. So you can see that an applied force can be resisted by a number of forces, such as friction. If it's going in a positive or a y direction, it can be opposed by the normal force or by gravity. A preview of results. This lab compares constant velocity motion through experimental data using Tracker and through coding based on the average velocity on GlowScript. This means that the slope of both graphs is nearly linear, with the computed data being exactly linear and the Tracker data being almost linear. This video shows the glue stick, which is the system in this lab, and the surroundings, which is the countertop in the room and the air around it. It moves in the left here, which is the positive x direction in this experiment. So the initial conditions for the compound computed slope were found through the initial x value in the tracker, and the initial slope was found through the average velocity equation. Final position minus initial position divided by the change in time. You can see that the average velocity was computed as 0.157, which was using GlowScript to calculate the initial velocity. The code here, you can see the initial velocity right here, 0.157, and the change in time, 0.01 per every loop until 2.002 seconds. So you can see here that using the position update formula, the ball velocity, which is up here, 0.157, times the change in time, which would be 0.01, is added on to the position to find the next position until you find the final position at the final time. This is the graph that is shown through this computation. You can see that it's completely linear, as it's based on an average velocity and a truly constant velocity, compared to this graph where you can see a true linear slope in one of the graphs, which is computed, and a curved slope slightly, which is the tracker, which instead uses different x positions over intervals of time, which is less truly constant velocity than the computation. So what are the differences in physics principles between the two graphs? The computed slope was created through repeated application of a constant velocity that was found through the use of an average velocity formula, understanding that the velocity final is equal to the velocity initial, which is also equal to the average velocity. The observed shape was found through the creation of an xy coordinate system and describing the x position of the glue stick at various time intervals. The reason that the slope is not constant is minimal, but apparent outside forces acting upon the glue stick and human error when operating the tracker. What if the axes were flipped around so that the x is the negative x direction? The glue stick would have been traveling in the negative x direction. This means the velocity would have been in negative and constant. The position time graph would be relatively linear, but it would start at 0 and go diagonally down to the right, which you can see by my drawing. What does it mean? No, because you would not be able to calculate the force because everything exerts a gravitational pull on each other. Knowing this, there would be an infinite number of forces acting on the glue stick, something that is close to impossible to calculate exactly. Thank you.